Find the intervals of increasing, decreasing, and maximum minimums for f of x. We'll start by using the derivative to find intervals of increase and decrease. The derivative, we get 36 minus 6x minus 6x squared. From here, we'll set this equal to 0 and factor. So I'm going to start by reordering it slightly. Factor out the GCF, -6. Then factor the quadratic. Set each factor equal to 0 and solve. And it looks like we're getting 2 and -3 as our critical values. So we'll put those on a number line. Notice that those two values are splitting up the number line into 3 different intervals. From here, we'll create a table. We have our intervals. The factors. What that tells us about f prime. What that tells us about f. So the intervals are to the left of -3, between -3 and 2, and to the right of 2. So -6 will always be negative no matter which interval it lies on. Looking at x plus 3 now, to the left of -3. If we picked a number to the left of -3 and plugged it into x plus 3, we would get a negative. And then picking a number between -3 and 2, plug that into x plus 3, we get a positive. Pick a number bigger than 2, plug it in, and we get a positive. Then going to x minus 2 and doing the same thing, we get negative, negative, positive. Now for f prime, we're multiplying across negative, negative, negative. 3 negatives when multiplying would give us a negative. Negative times negative is a positive. And then negative, positive, positive will give us a negative. So a negative derivative means that the f is decreasing on that interval. So we're decreasing from -infinity to -3. A positive derivative means that we're increasing on the interval from -3 to +2. And a negative derivative means that f is decreasing on to infinity. Now we're looking for where there is a change from increasing to decreasing or vice versa. Notice in this first change, we go from decreasing to increasing. That means we have a local minimum at -3. So f, if we evaluate f at -3, we'll get the value of that min to be -81. And then we also have a change going from increasing to decreasing. That means there must be a local max. It occurs at 2. If we evaluate the original function at 2, we can get the value of that max to be 44.